All right, how are we looking? Looks like we got sound. Let me off the YouTube chat. I still have to do each time. Okay. All right, jumping right in tonight. We are working on the Neko kitty. So if you're interested in this, if you don't know what's going on or you want to see previous videos about this same project, you can watch the last couple of videos on YouTube, or I think they probably exist on Twitch as well, at least for a few weeks or something. So you can watch that to catch up. But basically, we have this cute little cat animation running around, and what we want to do today is make it be able to go to a spot. Right now, it just kind of picks where it goes randomly, and we want it to be able to go to a specific spot, and eventually the spot that it goes to will be where we touch on the screen. And I think we'll put a little red dot there, like it's a laser light. I think that's a cute idea. But really, it doesn't matter, right? It doesn't matter where the spot comes from. Generally, we just want to make the animation be able to run to a spot. So that's what we're going to do. We have this Neko animated sprite. We can, I think, just make something like... how do we want to do this? I think we want to have like a moving to, and it will either be none or it will be a tuple with a screen location. Let's see here. Do we want to make it? I think we want to make a property. I think we want to have a property that we can eventually set and retrieve. So let's go inside of init. Let's go self. Self. Moving to. I was gonna say target location. I think I like moving to. Moving to, and it's gonna be none by default, but it could also be a tuple with an XY position, which will be some pixels on the screen. We will have property moving to property to turns moving to, which is going to be a tuple. Optional, I guess, optional tuple, because it can be, I don't know if this is the right syntax. It can be none also. So tuple XY location, we are moving towards, or none, not moving to anywhere specific. Moving to, we need a setter also. Write the setter out, so we're gonna go moving to setter if doesn't want to over much. Well, we yeah, you don't do the doc on the setter, so this one is going to be self dot moving to the field, I guess that is, or whatever the variable equals the new moving to. Okay, so we can set and retrieve that, and now inside update gets called each frame that we render from the main code. The main code is basically a while true loop that just calls update. So inside update, we will... So we want to do all this before we move or anything, before we move or change states or anything, I think we want to do this first thing, basically. Basically, what we're going to do is check our current location, check the location we're moving to, if it's not none. And based on those two values, we're going to set the state to whatever state it needs to be to go towards the place we're going to. So we have all these states moving up, right, left, down, and then the diagonals up, left, right, down, right. So we just decide which one of those we need to be in order to go towards the moving to point. I think we go if self to. It matters if we use the getter property versus the internal thing. So if it's not none, we basically need to figure out where we're at and compare it to where we're going, and then make a decision about which direction And I think we want to make it to where the center of the cat will aim for the point. That should probably be the goal. The center of the cat will go to the point that is set for moving to. So we should also make a property that will get us the center real easily. So let's go. Should be called something more specific than moving to. Moving to location. We have is moving already, but is moving is really more about the states, not the moving to. But the moving to will in turn set the states. I think everything still works out all right. But let's go property. Oh, that was interesting. Center point. Turn self dot x plus, no, it should be a tuple. Self dot x plus half of the width, self plus self dot tile width over 2, comma, self dot y, because this is top left corner of the tile grid, plus dot tile width over 2. That will get us to the center of the tile grid, is our cat. So we can compare that point to where we're going to, which we're going to go back to update. Update right here. No, right here. If moving to, then let's say if, let's see, what do we, this works. So we're going to, say if self dot moving to 0, which is going to be x, if the place we're going's x is greater than self dot center point 0, which again is x, if the place we're going to is to the right of where we are currently, see, here's the thing too, though. I want to make sure that we also do the up and down, and I don't want to write a million branches to this if statement. The place we're going to is to the right of where we're at. gonna be a bunch of branches? Maybe. Let's start doing it and see how it goes, and then we can try to think of a way to refactor it if it's bad. If it's less, because we also have the case where it's the same, in which case we would not move horizontally, but we might still move vertically. Okay, so if we get to here, we know that we're gonna move either right, or up and right, or down and right. So once we're inside of here, we're gonna say if self.moving to y, which is 1, is greater than self.centerPoint 1, which is y. So the place we're going to is below where we are at currently on the screen in pixels. We just want to update the state? Yeah, I think so. Self.current state equals state, what are the states called? Or what does this expect? New state. Okay, they are just state. Okay. Not it equals. Oh. So yeah, I need to try to figure out make them. No, maybe they should be static or something. Self.state. So this means that it is both below us and to the right of us. So this would be state moving down right. Elif less. This one's going to be down. No, this one's going to be upright. Moving upright. So else this would be the equal state. They're equal, which is, I should be more specific, maybe the x. Same x position, same x position. Well, no. This is actually the same y position. Y position. So in that case, we would go directly to the right. Because our x was to the right of us, but our y was the same. Moving right. Here, I guess we're going to have pretty similar stuff. Just be down and left. Up and left. Regular left. And we need also else here, which would be same x position. And then we would loud sounds from outside. If the x's are the same, we want to know if the y is different still, and if it is, then we could move up or down, basically. Down. So if the y is greater than higher pixels, that means we move down on the screen. We go moving down. It's less than, we go moving up. And then the else here we don't need, because it would be else we're in the same X position and the same Y position as where we're going, in which case we don't do anything. I mean, I guess we could do something. We could do, like, go to the sleeping state or something. Randomly choose between the sleeping state and the cleaning state. I guess really what will happen is it will overshoot it, because it'll keep moving if it doesn't change states when they're equal. It'll keep moving whatever the last direction it was going was. So then it'll get past the point that it's going to. Maybe we should have an extra check that says if the point that we're moving to is anywhere inside of our tile grid, or do we want to be on the exact pixel? So we won't always be able to hit the exact pixel, because it moves by steps of 10. Step size. It moves by steps of 10. So let's think about that. Do we want to, whenever we get told to move to a spot, do we want to, like, snap it to the grid of 10s? Do we ever end up not on a 10s? Let's try, well, and I guess the center points would be on the 5. Print go dot. Let's try this. What kind of values? If this is always on the 5s or what? Yep, always on the 5s. Well, the 5s and the 0s. Always on things divisible by 5. So if we told it to, like, move to, 17. Not always on 5s. Scratching and we're on 17. Oh, you know what? We artificially snap to the wall. Whenever we get close enough to the wall, we move to one or 2 pixels. I forget exactly how far. 1 or 2 pixels away. So when we got close to the top wall, the top edge, then we moved like 1 pixel away from it or 2 pixels away from it, which broke us off of that grid of things divisible by 5. We're still changing by 5 every time, but now we're on a different shift amount, basically. I don't know, there's probably a better term for it. It is still true, though, that we're not always going to be able to land on the exact dot where we're told to move to. So maybe we should say, like, if the tile grid is on top of the dot at all location, then consider us having got there. Could even snap too, I guess, really, right? We could just check if the dot is underneath the tile grid square, and if it is, then move it to be centered on that, so it'll look like it took the last step. Might be a small step, though. Or a big step? Yeah, could be bigger or smaller than normal, because it's 32 by 32, I think. Okay, so I think what we do is... Well, we should have definitely some logic that changes moving to back to none if we get there. Where we would check it. So we are moving to a spot. Yeah, so so what do we want to know here, basically? We want to know if the x is less than x and this is less than so if the x is within the range of the tile grid, the moving to x, shouldn't be x though, this should be 0. Then duplicate indent y 1 y. Oh, you know what? I think where was the last place I used tile width? Did I use tile width twice when I should have used? Feeling like the last time I used tile width, I probably... Ah, yeah, center point. It was on center point, and this totally should be height. Okay. So if both of these are true, then the point we're moving to is within the box that our tile grid occupies, in which case let's go self dot current state equals random choice cleaning it'll go there and stop basically, and then eventually start moving again. Maybe also set moving to back to none. Yeah, I think so. So I think let's just try doing here like Neko moving to 1010. Oh, right, this is not a function. That's still pretty good. Covering it up. Right. So I'm gonna start in the center. Oh. It broke. Oh. So we didn't animate for one thing. Not animate. Set the state, then animate, which either would have animated or not, and return true. Maybe we. Now, last animation. Time was too. Or we have this. Much stuff in it. Okay, let's put some stuff like print. Made it. And we're expecting that we should be going up and left because we're starting in the center and we're telling it to go to 1010, which is near the top left corner. Print moving up left. That happens. Yeah, we're not animating, and okay, so we need some we need either we need logic where the cat knows it's touching the top wall and then runs left instead of diagonal, or else we need to not tell it to go to a spot that's too low on the pixels, right? If we just don't tell it to go to a place that's less than half of its size, since we're basing it off the center, then it should always decide to turn, not use the diagonal one anymore. It never did do this time. We always got moving up and left, and then eventually it says we made it, but then it failed on 95. Right, so we set moving to none, and then we immediately try to check it as though it's a tuple. I guess we can have another if moving to. That feels kind of weird, though. We're still moving, basically. So we started out moving to, and then we noticed that we made it. I guess, I mean, we can't really check this before the first one because if moving to is actually none, then we'll fail the same way here. It's going to try to subscript it. We not be animating. We're always changing states. What happens when we change states? Changing states is resetting the animation time, isn't it? What are you? Got his little quick thing. State setter. Yeah. Always setting the animation back to. So we should only change states if we're. We should only set the state if it's different than the one we're already in. Means we get more branches on all of these. I think Pilot was already mad about the branches, but we're gonna have a lot more now. Maybe there's a more elegant way to write this part of it. I don't know. So if we're not already in this state, then set ourselves to this. That way we don't keep changing, we don't keep setting the state over and over again, which is then ultimately resetting the animation time, making it so we don't animate. Okay, every time we set it, check it first. Actually, no, let's not do this. Say here, if current state not equal to state. So inside here, we just don't update it. Yeah, we shouldn't do any of this. So this will be the same logic, but we only need to put it in one spot. It will always take effect. How should it animate? Then it should arrive there as well. We might still have the problem. Yeah, we do have the problem, like we hit the wall and then kind of do like a running sideways but animating diagonally type thing. I think that's because our moving to is too big. Lamped move to equals a tuple, which has what do we want here? We need it to be at least half of the width. In our case, it's 16. We could just hard code it to 16, I guess. Less than 16. Hard to do this with tuples because we can't change things. And we could just have like min new moving to 0 and then like, you know, half the tile width. The problem is we need it to clamp on the other side too and on the bottom. So we need to make sure that we're not less than half. We also need to make sure we're not greater than display size minus half. Okay. Clamped moving to equals none. If new moving to x less than probably enough by one error waiting to get me here. It's less than self dot tile width over 2. It's a list. This is going to be such an awkward. There must be a better way to write this. Yeah, if it's less than that, then set clamped moving to 0. Do this. If it's greater than. Hey Keith, doing pretty good. How about you? It's greater than display size 0 minus tile width. Go close to the right edge. Then we go clamped this value. See, but then it gets weird because we need to check if we have things in clamped moving to and then use that instead. We also still need to do the y values. And we might try to... Okay, yeah, we're not going to do this. We're going to say clamped x equals none. Clamped y done. Get some filtering work done for the subreddit, then work on a couple PRs. Nice. CD at 4x CO2 sensor. Oh, I need to look back into something that was going on with the typing. That reminds me. This is going to be clamped x. Now, actually, why don't we just say clamped x equals new moving to x. So it starts on the one we gave it, and it only changes it if it needs to. But this should not be y. Yeah. Now we can do y. So now we say basically these, but this is y, and this is height. This is height. And that's y. Now 1 height. Okay. Now we can just do clamped X, clamped Y, because it will either be the original one or the one we changed it to. SCD4X, CO2 sensor. I don't know if I've ever played with one of those. I don't think I have CO2. I have some like humidity sensor. I have a couple of stemma sensors. And some of them just like I didn't really have a use for, but I grabbed them. Also got a couple of the free ones. Stemma ones are nice though. Once you have enough wires and things that use them, like main boards that have the stemma connector, it's like Legos at that point. It's nice to just have a bunch of random ones that you could always grab and plug in and use without having to think about. Okay, so this will then basically, we're going to tell it moving to is 1010, but it should change it to 1616, which I guess is still technically wrong probably, but we'll see what it does. Probably, you want 15 because we're 0 based. Don't stop on the edge. I know that didn't change the animation there at the top. It made it amazing. Their test. How nice. Yeah. Yep, totally agree. No soldering or anything. So we still failed here. What did we fail now? 204 moving to? Kind of subscripting problem still. Or right. If we set it to none, then it would give us that problem again. So whenever it got to the end and it set it to none, then it failed. It did still stay diagonal at the top though, which I was thinking maybe it would turn. So we basically want if new moving to, then do all of this. Otherwise, it is going to be none. Okay, yeah, diagonal. It did stop when it got there though, which is nice, but it was doing that like running diagonally across the top. I'm trying to make the cat run to a specific spot. That's what I'm working on tonight, Keith. That's the beginning, I imagine, although I'm sure that's become clear. I think so. One problem is I don't have the touchscreen hooked up. We should probably hook up the touchscreen sooner rather than later so I can touch new spots and have it go there. Right now, it just starts in the center, and I have it hard-coded going to 10. Why do we never decide to turn to the left? Maybe I was off by one the other way? Was I off by one the other? Okay, let's look at what moving to got set to from the clamped one. So we can just print moving to afterwards. Let's also get rid of this moving upright print. We don't need that anymore. Up left. Keep we made it. That one won't spam as much. Okay, 1616. Okay, I'm gonna start further to the right Make sure that we're not just like getting unlucky with the number of tiles versus the animation speed or something. Like maybe technically it would be changing, it just doesn't have enough time. So instead of starting in the middle, we're gonna go we're gonna comment this, duplicate it, divided by 4, and then three, in 3/4. Do this, and then do this, and then subtract. Makes sense. Let's start 3/4. Yeah, pretty close if not. So do we sit in the diagonal state all the way along here? Yep. We're also not animating anymore, which makes me think something else is changing the state. Something is changing it and then changing it. Do we ever get this? Same. Print. Changing to move left. Do we ever see that? No. So print place we're moving to, place where we're at. See how close we are. I'm probably just by 1 still or something. Yeah. So we get to 17, but we don't get to 16. I have more. That's the logic that's moving us 2 pixels away or something, I think. I'm surprised we don't. Well, we do probably. We probably instantaneously change to the scratching state, but then change right back to running diagonally the next time through. I bet you we're actually tripping the thing that's making us scratch the top. We don't have a thing? No, that's not true. We definitely have a thing. Well, we definitely have a scratching. It's and it's up. Which is saying This is how it knows we hit one of the two walls. It's basically our current y is either less than 0 or it's greater than well, no, the current y plus the movement step in the y position. And display size minus tile width. This is where the formatting from black, I really think, made this less understandable for me because it's a three-way if. So it's, is this one in the middle, basically in between these two values? So is the y plus the movement step of the state we're in is the place where we're gonna go, basically, if we take a step. The place where we're gonna go if we take a step, is it less than 0? Or is it greater than the display size minus the tile width? So basically, is it off the top of the top edge of the screen, or is it also starting to go off the bottom edge? It touched either edge, basically. We ran into the top wall. We set y. When we ran into the wall, we go set y -1. Ran into the top wall. We set y to 1. We set the state to scratching up. This is probably happening, but then we're immediately changing again because we're in moving 2. I think we want. I don't think we want to stop and scratch the wall. Since we're moving to a spot, we should keep moving there. So it does work to our benefit, actually, that it's going to change to scratching and then change right back to moving. But it is going to mess up the animation. So it doesn't work to our benefit in that sense. We are basically just off by 1, though, because of this 1 here. So if we did, whenever we clamp moving 2, we could just change it by 1 more, and then it should work. Make it turn. We want a plus 1 here and a plus 1 here. And a -1 here. Here. Now we should hit 17 and then turn to the left. Yep. Okay. I like that better. That looks pretty good. Did the animation get messed up at the top? It's kind of. Let me watch directly on the screen. One more. It does feel a little more skippy to me. Even while it's Even while it's running diagonal, it kind of feels like it's stuttering a little bit. Let's let it run for a little while after this, see if it looks normal. Nothing else will set the moving to. That all looks fine to me. Okay, we should get the touchscreen hooked up so that I can tell it to move to more spots. This, we're gonna grab the simple test from screen. This happens to be already set up for PyPortal, so it works out for us. Oh, I guess we should make this conditional. Go back and do that afterwards, because it won't work. I did get this running on the Clue and the Funhouse as well, and it doesn't have touchscreens, so it won't have this functionality. What are we missing? Oh, I missed a parenthesis here. Do this. Okay. Let's just do that and see what it prints. Let it get to its spot too. Well, we're not actually doing anything when we touch. Oh, but it is going to keep printing more stuff. Let me turn that print off. Need to see that anymore. Oh, maybe that print's slowing it down, actually. That's probably where our stuttering is coming from. It's only affecting when we're moving too, because that's the only time we're printing. Totally have seen that before. Printing, it turns out, does take a meaningful amount of time when you're trying to update stuff on the screen. Yeah, because that looks totally smooth now to me. I mean, as smooth as normal. Maybe a little stuttery on the left run, but the diagonal looked fine. The left, I could believe, is still messed up, though, because I do think it's probably still changing to scratching and then changing back to moving left. I'm surprised it's animating, actually, because I would think that would make it reset the... resetting the animation time. And also resetting to the first frame. The animation. Anyway, now we can touch. So it looks like we have X, Y, and then I think it's a pressure is the third one there. So let's go when we touch. Well, put some limits on this first of all, I guess. Let's not spam it too fast. First we need to tunes on real quick. There we go. Let's say something, putting like non-configurable, not really meant to be configurable stuff down here. Let's say like touch cooldown. Let's ignore touches except for like once a second, I think is plenty. 1.0 last touch time -1. You just ignore it all together, I think so. Now equals time dot monotonic if now is greater than last plus cooldown. Then do this. And last, this equals now. So discard all of them except for once per second. It kind of stutters once it gets almost there. I wonder if there's something weird with that. Okay, yeah. Much slower touch events. You keep your finger down, it does still keep sending them, but only one per second. Much more manageable. We don't want to... I guess I don't know how bad what it would do, but we don't really want to spam it that much. I don't want it to be like setting its move to all over the place. Too fast. Once per second is plenty fast. So here, instead of print, we're going to say Neko.moving to equals E0, oops, E1. So we're going to go moving to place we touched. Forward. So can we interrupt it? Here. Sure looks like it. We got there and stopped and cleaned. Randomly decided to go to the bottom. Touch up there to make it go up there. Ooh. That's a little weird. What was that about? It's like it... I kind of like the little dance it does, but it's moving between the diagonal. It's changing back and forth between the diagonal sprite and the straight left. So I guess the problem is the logic that we made is specific to the edges. We're running into the problem where would it be doing that actually? I don't know why we're doing that. It's cool that I can tell it where to go though. I do kind of like that. So when it gets to the same horizontal level, the rest of the way there, it does that weird hippity hoppity. This little number here, which I actually find really funny. Oh man. Okay. Wonder why it would be doing that. I don't have very many great ideas on why it would be doing that, so thought I find it amusing at least. Programming animations and things is always fun when it graphics in general really is always kind of fun when it goes wonky on you and makes something funny. Go shuffle. So I guess we're gonna have to turn some prints back on. Could both be true? They can't both be true, can they? Because one of them is an else. So let's take, for instance, when we decide... Yeah, so we're basically like going back and forth between like these two. We're deciding to go up and left, and then we're deciding to go just left. Same thing on the right side, it seems to be, but this is if else, which means we can't possibly do this and this in the same frame. So we do one frame. Moving up left, which causes us to animate, which causes us to take a step up and left. That gets us to the same Y position. Which puts us into state moving left. Why would it ever go back though? If it's in, once it gets to the horizontal moving one, then it's not changing the Y position at all. So whatever one of this branch it went to before, it should always go to the same one, because Y no longer changing if it's on moving left. Whoop. Thing on the wrong screen. That print? Oh, okay, this is only if we're moving left, which is why it didn't actually print anything on the one that we were Okay. We're bouncing back and forth between... Okay. I get it. I get it. We're not going back and forth between diagonal and sideways. We're going back and forth between diagonal up and diagonal down. So we're not changing back and forth between up left and regular left. Instead, we're changing back and forth between up left and down left. And the reason why is because the place where we told it to go to was y value 120, and we happen to be misaligned. We can hit y value 117. We can hit y value 122. Cannot hit y value 120 unless we get offset by 2 pixels somehow. So we can't check the exact pixel. We need to, if we're close enough, then count us as in the right spot. So if the place we're going to is greater than the center point, I feel like there's a way we can just do step size? Do we do step size or step size over 2? Basically, we want to make it a little bit harder to be in the diagonal state and a little bit more likely to be in the horizontal state. We want this else range to be bigger, which means we need these 2 ranges to be smaller. Is that right? Plus, so we want to know not only is it greater than, not only is it to the right of our center point, it's also, well, actually, this is not to the right of our center point. This is below our center point in the y orientation. Target point x minus, oh, going squared. Target point y. Enough distance. Very well could be. Point x. What is the squaring? What is this like way you solve for being within radius of the target? I think I'm okay with being in the being within a square. I don't necessarily need to be in the radius. But if I'm within the like if it's, well, really what it is if my center point is within the 10 by 10 pixel square centered on the point where I'm moving to. My center is within 5 pixels of the point where I'm moving to. So we do, I think, need a divided by 2 on this step size. Not convinced it's in the right part of this equation, though. I don't know how much more pixel geometry I got in the brain for the night. Yeah, for sure. It's always fascinating to me to see different ways people tackle different things. So maybe it is plus. Talk myself back into this. Would this one be minus? The y point of the place we're going to is less than the y point of, if it is above the y point of our center. Yeah, it feels like it should be minus. Now basically, instead of being exact same y position, we can be somewhere in that range. Sound update thing. Like the last 2 times I updated that sound thing, it stopped working, so I never update it. Gives me this pop-up every day, multiple times a day. So on this, probably still have this, don't quite have this. Oh, right, yeah, so definitely I don't have this right, because we don't need it here. On these ones. And I guess it's going to be on these ones too. I don't have a good feeling about it being right. This one is the same as this one. Duplicated? Yeah, well. Oh. I mean, it's not duplicated because we're setting the state to something different, but it's kind of similar. I'll give you that, I guess. More similar than I would like it to be. But when it's on the wall, we're fine. Okay. That time it worked. Yeah, that's pretty much the effect I'm after. Yeah, I like it. I am super surprised that that actually does what I wanted it to do. I'm gonna be real honest. I think I'm probably gonna wrap it up for now because I'm just not really visualizing what all these points are doing anymore. For a while I was on a roll here, kind of be one with the cat and figure out where we're going and where we're at and all of that, but I've hit the limit for the night. Certainly hit the conscious limit, but apparently my subconscious can carry me a little bit here. You know what? I'm gonna do one more thing. Actually, you know what I'm gonna do because I think it'll be quick. Is draw a dot where we touched. CircuitPython. We're gonna go vector IO for it. Vector. Circle. I feel like this circle is gonna be a lot simpler to realize where it's at, what it's doing, because it doesn't interact with very much. Palette we're gonna make, it's gonna be red. I guess technically they could set the background to red. You wouldn't be able to see the dot. I think I'll make the dot configurable too, though. Maybe they will be able to turn it on or off, or maybe they could set it to a different color if they want. Radius 25 seems pretty big. Let's go. I mean, it's a laser pointer. It should be small. Let's say 4. Yeah, let's start there. I think it doesn't really matter what we put for X and Y because we're gonna move it when we touch. I think that circle is centered on this also. So if we go circle X equals circle Y equals. When we touch, we move the circle. The other thing is, I think, if not, Neko.moving to, if we're not moving to a spot, which means either we just weren't moving to a place at all to begin with, or we already made it to the place where we're moving to, then we will hide the dot. I think I can put this negative. If not, there's other ways I can hide it and show it, I guess. I could remove it from the group or something. We can just set it to negative, though, and that'll make it off the screen. We haven't touched yet, so therefore we don't actually have it. Let's turn off our first one of these. We don't really need this tester anymore. Okay, so we're gonna touch. Either we did not register, something broke. Let me turn off this print again. Oh, also we're not scrolled. Okay, there we go. Red dot where we touched. It's still a little big. And when the cat gets to it, it goes away. It's resistive, so you got to give it a good poke. It's not capacitive like we're used to our phones, which are capacitive. You just have to touch it. This is actually the flex. You're like pushing it down into a mesh or something. Make it complete a circuit. I'm not sure exactly what it is, but you got to push pretty hard. Stylus helps too. Do we want to do anything else right now? I move it. It does ignore touches. Okay, yeah, we can move it while it's running too, so we can just make it run back and forth here. It's kind of fun. I think it is a little big. Two look like. Is that too small? Yeah. Cliche, but I think we're gonna go in between. Maybe 3. But it does ignore my touches sometimes. Yeah, I like 3. So it's supposed to ignore touches except for once every second to filter out like spam. But it does seem to be ignoring more than that, truthfully. Should get out of stylus though, probably, and like maybe when it's in that one, I think I was too fast, probably. Also, while it's doing one of the longer animations, it seems like it ignores touches. Which kind of seems okay, but I'm also not sure why it would do that. Because the way we're calling update, we're only doing one thing each frame. I would think we should still be able to listen for touches during one of those longer animations. Might be something I'm misunderstanding, but I'm pretty happy with that. We got our move to going. We even added the laser point for it to move to. Cat can catch the laser point. We could turn it off, move it off the screen. We managed to fix our little diagonal stair-stepping problem there. Pretty happy with that for the night. So I think I'm going to head out. Thank you to Keith for hanging out. I hope you have a good rest of your evening. Anybody else who's watching, thanks for watching. And I'll be back on, I think, Saturday probably. Next time I'll stream Saturday morning in the normal time, 10 a.m. Central. So I'll catch you later.